So earlier we looked at part A and then part B in different videos. Now we're ready for part C, and this is the CSEC Mathematics January 2025 paper question 4. Alright? Now for part C, it says determine the equation of the perpendicular bisector of CD. Now remember, I make this video, these videos, they follow each other, right, one at a time. So there was part A, then part B. So if you haven't watched part A and B before, you should watch it. Alright? So let me paste that part of the question here as part C. You're to determine the perpendicular bisector. Now remember the term perpendicular. It means at 90 degrees, right? Bisect means it passes through the midpoint. Now, the midpoint. What was the midpoint again? We just quickly calculate it again. The midpoint, you have -5,672. So the midpoint is the average of the x's. That's for the coordinates. x1, which is -5, plus x2 is 7 over 2, comma. Then the average of the y's, 6 plus 2 over 2. So it's going to be 2 over 2, which is 1, comma. 6 and 2, 8 over 2 is 4. So the midpoint is located at 1, comma 4. Alright? Now the perpendicular bisector would be at right angle to it. Now I don't want to crowd that diagram too much, so let me just redraw. So here the midpoint is at 1, 4. Now the perpendicular bisector would be something like this. A graph. A straight line passing through the midpoint at 90 degrees to it. Alright? Now, you must remember the relationship between two lines that are perpendicular. What happens with the gradient? You have to remember that when two lines are perpendicular, the gradients multiply to give -1. Right? Now this line was CD. Here, what was the gradient again? -1/3. So the gradient was -1/3 for CD. Let me just make this look more like D. Okay, good. Now, what should the gradient of the perpendicular bisector be? Let me say PG, PB is gradient of the perpendicular bisector. I just make up that name. The gradient, first of all, let me not do that yet. All right. The gradient of the perpendicular bisector multiplied by the gradient of CD is equal to, remember what it was? -1. So the gradient of the perpendicular bisector would be -1 over the gradient of CD. It's -1 over -1/3. And that would be what? +3. So the gradient of the perpendicular bisector is equal to 3. Alright? Now, remember the general form of a straight line is y is equal to mx plus c, where m is the gradient. We have part of it here. We know the gradient. So y is equal to 3x plus c. Now c would be the point where the line intersect the y-axis, alright? Well, it so happens that C is a perpendicular bisector where it passes, where they intersect would be 1, 4. They intersect at 1, 4. We could use that to find C, right? Now, here, we have an x and a corresponding y. The x is 1, the y is 4. So, where x equal 1 and y equal 4, because that's where they cross, right? Y is equal to, no, it's not y, I should say. I know y already to be 4. 4 is equal to, let me write this under, instead of writing it beside. So, at x equal 1 and y equal 4, y, which is 4, is equal to 3 times 1 plus c. So 4 is equal to 3 plus c. If we subtract, c is equal to 4 minus 3, which is 1. So it would intersect at 1, right? The y-axis. It would cut the y-axis at 1. So, oh, I had written the 1 for too near. It would be more like this. So, the perpendicular bisector would come down about here. So, hold on there. 1, 4. Let me just verify something. It goes to 1 and then 1, 2, 3, 4, right? Right. So, we have the perpendicular bisector somewhere there. So, here now. Y equal mx plus c, y equal 3x. 4 is equal to, was 1, 4. 4 is equal to 3 times 1 plus c. 4 minus 3 is 1. So the gradient, the equation of the perpendicular bisector would be y is equal to mx, which is 3x, plus 1. Now remember, x and y, they keep changing, so you don't have any specific number for them. But the fact is, at one instant of time, we know what the x and y were when they intersect, right? We know the x and the y. Now it so happens that the perpendicular bisector, the perpendicular bisector is here, but it's okay. I had said earlier that I should have drawn it nearer, but some distance down, but it's okay right here. This is where the perpendicular bisector would happen to be. No, let me see, 1, 2, 3, 4. No, man, what am I talking about? If you have the line like this, the perpendicular bisector cuts it at 1, 4. So it would go down somewhere like this, right? Just want to visualize what it would look like. The 90 degree would be like this, somewhat like that. Right. So the equation of the perpendicular bisector is this. Y is equal to 3x plus 1. Let me see what else they say. Another line AB is parallel to CD and pass through 0, 1. Write down the equation of AB. Alright. AB is parallel to CD. AB is parallel to CD. Passes through 0, 1. So if it passes through 0, 1, 0, 1, what would it look like? Somewhat like this. I have to drag it down. Probably look like that. Alright. Now, remember, alright, before we do that, AB parallel to DC. Yeah, so this is AB. Remember what you mean by parallel? They have the same gradient, right? So if AB is parallel to CD, it means the gradient of AB is equal to the gradient of CD. What was the gradient of CD again? It's negative 1, 3. So the gradient of AB, negative 1/3. The gradient of AB is negative 1/3. Alright? That's the gradient of AB. Now, y is equal to negative 1/3 x plus c. So, here, we need the value of c. If we could find a y and an x that correspond, then we could get c. Well, we are told that they pass through the point 0, 1. So, at 0, 1, x is equal to 0 and y is equal to 1. Right? Now, y, which is 1, is equal to negative 1/3 times 0 plus c. But negative 1/3 times 0 is 0. So c would be 1. Alright? So, y is equal to negative 1/3 x plus 1. Alright? So y equal negative 1/3 x plus 1 is the line that we have. Alright? So negative 1/3 x plus 1. Alright, so let's see what else going on. That's it for question 4. Alright, I'll see you in the next video then.